7.3 says the tangent to the cubic function g has a minimum gradient at the point -1 and -7. For which values of x will g be concave up? So for explanations, I've drawn a diagram on the side which shows the tangent to g, which is a cubic function, has a minimum gradient at the point -1 and -7. So if this graph, which they're referring to as the tangent to g, has a minimum gradient at that point, it means that's the point where concativity changes. So if we were to work out the first derivative of our function, this would be 3a x squared plus 6x plus b. Then we would work out the second derivative because we know concativity has to do with the second derivative. This will be 6ax plus 6. Then basically the minimum value on our second derivative, or in this case the tangent to g, on this function, the minimum value also represents the point where concativity is 0, and concativity is represented by this straight line here, which I'll refer to as, I'll just say c of x. Not that it's necessary, but just to show that this x value is related, which means that on this function, when x is -1, on the second derivative, when x is -1, the value of the concativity is 0. So we can substitute x with -1, would have 6a -1 for x is equals to, actually plus 6 is equals to 0. Take 6 to the other side, you get a is equal to 1. Then you can say, therefore, the second derivative is equal to, since a is 1, it will be 6x plus 6. And since we're looking for the values for which g is concave up, then you can substitute and say 6x plus 6. I want the values of x for which this is greater than 0. Take 6 to the other side, you get 6x is greater than -6. Divide both sides by 6, and you get x has to be greater than -1. X has to be greater than -1. There you get a positive, it'll basically be concave up from that point. Another way you can reason about it is, if you know that the minimum of the gradient occurs at -1, because remember this is the gradient, they're referring to it as the tangent, and they tell you that it is a minimum gradient at the point -1 and -7 at that point. So if you know it has a minimum, it means that point x is equals to -1 is a point of inflection, and that's where concativity changes. So at that point, you will know that if I go to the right of -1, my graph is going up. Because if they had talked about it, if it was the other way around, it would have been the maximum gradient. But in here they refer to it as a minimum, which is -7, and would know to the right of that it's a positive gradient. And if this is positive, it means concave up, but the gradient this side is negative, so that's concave down.